Hey everybody, this is Emma Jacob and Courtney Brown, and this is Homework 8 for Engineering 460 at Liberty University. So Homework 8 basically says to look at the procedure above, that is written in Maple, and now modify the procedure to generate numbers from 0 to 1 using the following A and B formulas. So these formulas are actually developed, and we'll go through the theory real quickly before we go into our actual answers. So here's a theory. Hall and Doble in 1962 basically created a pseudo-random number generator algorithm. As you can see below, basically what it does is it, for your next random number, takes A, which are predetermined, A, C, and M are predetermined, and it says A times X sub I minus 1, your previous, plus C times mod M, and your I's are obviously from 1, 2, 3, until you decide to stop. And basically what they said in their theory was, here is a parameter on how to choose a good A, C, and M. What they said was that C and M are relatively prime, so their greatest common divisor of C and M is 1. A minus 1 is a multiple of Q for every factor of Q of M. And A minus 1 is a multiple of 4 if M is a multiple of 4. So in MATLAB, basically what we're looking at is here. For part 1, again, what we're looking for is for setting, again, this is our equation here. We want to set A equal to 7, our M equal to 61, and our C we can set as 0. And we can go through 100 number of iterations and set our seed as, or our start point as 1. And what we'll do is we'll go through it and develop this MATLAB code to generate pseudo-random numbers. And what this will give us as we go through this MATLAB code is it'll give us the period. And the period is going to be when we start to see repeating numbers. Now obviously we want to keep repeating numbers down, because the more or the smaller the period, the less random and the less we're able to actually use those random pseudo numbers. So that's for part A. What we want to do is set A equal to 7 in this equation for them. Now again, this matches what we wanted for the theory, that again back here where A minus 1 is a multiple of Q for every prime factor Q of M, and A minus 1, which was 6, is a multiple of 4 if M is. But obviously M is not a multiple of 4 because M was 61. So that's part A. For part B, all we do is now change this over to 49. We run the same thing, and the results for part A and B are as follows. For part A, we get a period of 60, and for part B, we get a period of 30. So let's check that out in MATLAB. Alright, so here we are in MATLAB. So normally this would be a linear congruential generator, but because we set C equal to 0, this becomes a multiplicative congruential generator. And again, we've set the same parameters that I showed you previously, and we can run this. And again, what this gives us is at a period of 60. So with n equal to 100, every 60 random numbers, we start getting a period or a repetition. Now if we change this to 49 like in part B, we can run this and we're getting every 30. And obviously the period happens at 30, 60, 90, which are multiples of each other, which obviously makes sense because we're setting n equal to 100. Now if we were to set, again, outside of what Hall and Doble talked about, so let's say at, A is 9, which is not, does not follow what they had said in their theory, we expect to get a very, very small periods, which we do with periods of 5. So that is how we can generate and actually prove that their theory is correct by Hall and Doble. Thank you for watching.